4 equilateral triangles. What's the area of the red one? We'll have to find the side length of the middle triangle to solve this problem. Let's start with finding the side lengths of the purple and yellow triangles. Although we're only given the area of each one, we can use the fact that they're equilateral triangles together with Pythagorean theorem to solve for their side lengths. We'll find that the side length of the purple triangle is about 6.8, and the side length of the yellow one is about 3.4. We know the interior angles of the equilateral triangles are 60 degrees. Now let's turn our attention to these 3 surrounding triangles. Let's label this angle A and this angle B. We know that A plus 60 plus B must equal 180 degrees. Simplifying that equation leaves us with A plus B is equal to 120, or B is equal to 120 minus A. Now let's call this angle Z. Because all angles in a triangle add up to 180, we know that Z plus 60 plus A must equal 180. Solving for Z, we get Z is equal to 120 minus A, which means that Z is equal to B. Let's repeat this process with this triangle. We'll solve the first equation for A and call this angle Y. In the same way, we find that angle Y is equivalent to angle A. Because these 2 triangles have 2 congruent angles on either side of a congruent side, we can prove the congruence of the 2 triangles with the ASA, or angle side angle postulate. Now that we know these 2 triangles are congruent, we know their corresponding side lengths. Let's take a closer look at the bottom right triangle. If we draw this altitude, we create a triangle with one 60-degree angle and one 90-degree angle, which means the remaining angle must be 30 degrees. From there, we can find all the lengths of this new 30, 60, 90 triangle. Now, looking at the triangle on the left, we see that it has a 90-degree angle and that we know the lengths of both its legs. Using Pythagorean theorem, we can find the length of the hypotenuse, about 5.9. Now that we know the side lengths of the red triangle, we can use the equilateral area formula from earlier to find the area, which is exactly 15.